Okay, I want to make a video about completing the square. And first, I want to talk about a trinomial that we do not need to complete the square, so you can see the difference. So let's start with x squared plus 3x plus 2 equals 0. This is a trinomial. I want to solve for x, and I claim we don't actually need to use completing the square. We can factor this trinomial, so we need to find the factors of 2, which add to 3. 2 plus 1 equals 3, and 2 times 1 equals 2. So I claim that we can factor this trinomial as this. Now, if two binomials, the product of two binomials equals 0, then one of these must equal 0. So that means x plus 2 equals 0, or x plus 1 equals 0. I can subtract 2 on both sides, and I can subtract 1 on both sides. So I have found that x equals -2 and -1. Now, the idea is that if you plug these numbers back into the original problem, that it will equal 0. Let's see if that's true. Okay, what does that give me? That gives me 4 minus 6 minus 1. Whoops. That looks better. 4 minus 6 minus 2 does indeed equal 0. Now, what about -1? -1 squared plus 3 times -1 plus 2. Does that equal 0? Well, that's going to be 1 minus 3 plus 2. And yes, that does indeed equal 0. So this is the solution to that trinomial. All right, let's try another one. Let's try one from the lecture notes. How about x squared plus x plus 2 equals 0? So for this, again, leading coefficient of 1, but I need to pick the terms of factors of 2 which add to 1. Well, the factors of 2 are 2 and 1 or 1 and 2, but those add to 3. So those don't add to 1, so this is not working. So we need to find some other technique that can do this. This is where I'm going to complete the square. When I refer to completing the square, I'm talking about when we learned factoring, this was a perfect square. A plus b quantity squared is a squared plus 2ab plus b squared. We're going to use this idea to solve this trinomial. So, first step, x squared plus x. I'm going to send that 2 to the right-hand side because it wasn't doing me any favors on the left-hand side. Now, I'm going to take the b term, which equals 1. I'm going to cut it in half, and then I'm going to square it. Okay, so that means I need to add 1/4 to both sides. All right. Now, I claim that the left-hand side is now a perfect square. I know because I'm the one that designed it. I designed it by cutting the middle term in half and then squaring that. So now this is a perfect square. Well, I need to simplify the right-hand side. So 4 times 2 is 8 plus 1, 4. So this looks like this will be -7/4. Okay. Now, I can take the square root of both sides. Don't forget we have to do plus or minus when you take the square root of both sides. So I can clean this up a little bit. I can also subtract 1/2. So x equals -1/2 plus or minus root 7 halves I. Because I'm taking the square root of a negative number, That's an imaginary number, so I get I. And the square of 4 is 2. So I'm left with the square root of 7 here. So these are the two answers that will solve that trinomial. Okay. And they are both complex numbers. All right. Let's try another one. How about 9x squared plus 3x minus 2 equals 0? This is our first one where it's not leading coefficient of 1. So the first step is to make sure that that is true. So I'm going to divide both sides by 9. Now I have x squared plus 1/3 x minus 2/9 equals 0. Okay. Again, I want to take my b term, which equals 1/3, divide both sides by 2, and then square those. Okay. So that will equal 1/6 136. X squared plus 1/3 x equals 2/9 plus 136 plus 136. All right, there we go. Now the left-hand side is a perfect square by design. It was x plus 1/6, and then that's squared. Let's try to clean this up. The LCD is 36. 4 times 9 is 36. 4 times 2 is 8. 8 plus 1, 36. All right, well, 8 plus 1 is 9. 9 over 36 is 4. So we can actually clean this up at this step. This will become 1/4. Okay, let's take the square root of both sides. X plus 1/6 equals plus or minus. Oh, if we take the square root of this, this is going to become 1/2. Okay, so this is 1/2. Now we can subtract our 1/6. There we go. So we have two answers here. We have x equals negative 1/6 minus 1/2, and x 1/6 plus 1/2. All right, well, what does that equal? That is equals negative 2 minus 6 over 12. And that looks like that's negative 8 over 12. So that would be negative 2/3. That's a solution. What do we have here? That's going to be negative 2 plus 6 over 12. That's 4 over 12. That's 1/3. So we have found that x equals negative 2/3 and 1/3. These are the solutions to that trinomial. Okay, so that's completing the square. One thing I want to show you is that we can actually solve every trinomial at once now that we've learned completing the square. Let's try that again. Okay, so let's just go in a general sense. Ax squared plus bx plus c equals 0. Now, a, b, and c can be anything. We're going to assume that a is not 0. I'll divide both sides by a. So I get x squared plus b over a x plus c over a equals 0, because 0 divided by any number except 0 is 0. Now, I'm going to make the left-hand side a perfect square, and I'm going to throw this to the right-hand side. So I have x squared plus b over a x plus b over 2a squared equals negative ca plus b over 2a squared. All right. Now the left-hand side is a perfect square by design. So x plus b over 2a squared equals negative c over a plus b squared over 4a squared. All right, I wrote that kind of sloppy, so I'll rewrite that. a squared. Now, let's go ahead and clean up this right-hand side and make our lives a little bit easier. So that would be negative 4a squared c plus a b squared all over 4a cubed. Okay, I'm just going to write a ditto right there. What else can we do? Looks like we could factor out a and a there. Negative 4a squared c. Oh, silly me, I just factored that out. Negative 4ac plus b squared all over 4a cubed. Now it looks like we can cancel an a there. This becomes squared. All right, so at this step, we're now at 2a squared equals negative 4ac plus b squared over 4a squared. All right, so this is this step. I'm going to need one more whiteboard to complete this problem, but we're almost done. All right, again, we were at x plus b over 2a squared equals negative 4ac plus b squared over 4a squared. Now, take the square root of both sides. So I got x plus b over 2a. Don't forget that plus or minus. 4ac plus b squared over 4a squared. Okay, looks like I can move the b over 2a to the right-hand side. And this denominator here is a perfect square, so I can take the square root of that. X equals negative b over 2a plus or minus root 4ac. It does look like I dropped a minus sign there. B squared over 2a. These have the same denominator, so if I want, I can write this all in the same denominator. Often people like to write it in this way, b squared first. So I'm going to do that because of convention. And right there is our quadratic formula. So we can use this to solve any problem that we may need. You may now use this quadratic formula for the problems we previously did with completing the square. So I hope that is helpful. Please let me know if you have any other questions.